Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will discuss the topic of S1, which is calculating mean and variance of data by using a coded information. Now, before I move on with the idea, one thing that you must acknowledge is that if, let's say, I have a set of data and let's say that set of data is represented by these dots on a number line, and if I add a constant value to each value of data, every value of data has a constant being added to it. Now, what you can see graphically over here is that if I compare mean of this data and the mean of this data, the mean of new data would shift by the same amount which is added to each value of data. So what I want you to conclude from here is that if a constant is being added to every value of data, then that constant can directly be added to the mean of data to calculate the mean of new data. And the same thing could be done if a constant is being subtracted, then mean would also be subtracted by the same amount. Coded totals means that a constant is being added to each value of data or a constant is being subtracted from every single value of data. If you recall the formula for the mean, which is sigma x over n in case of a raw data, and it is sigma fx over sigma f in case of the frequency distribution table. So if let's say a constant is being subtracted from every value of data, and instead of having a sigma x, I have a sigma x minus a. If I divide sigma x minus a by n, I will get a mean of x minus a. But I know that that means that since a is subtracted from every value of data, so for original data, the mean has also a being subtracted from it. So to get the mean of the new data, I can just simply add that constant to my mean value. So I calculate mean from the coded totals and I will just add a constant to that mean value. Same thing I could do with the frequency table as well. If I have x minus a, I could do sigma f x minus a over sigma f to get the mean of x minus a. And if I add a to it, then that will become the mean of the x, that is original data. So what you need to remember is that if there is a being subtracted, then you add to the mean. Or if there was a case where a was being added, then in that case you will subtract a from the mean to get the mean of the original data x. Now the other thing that I would want you to note by this number line is that if a constant is being added to every value of data, the scatter of this data about its mean is same as the scatter of this new data about its own mean, which means that the measures of spread of this data and the measure of spread of this data are same. Specifically talking about the standard deviation, if I could calculate the standard deviation of this data, that must be equal to the standard deviation of this data. So if I compare the scatter of this data about its own mean and scatter of this data about its own mean, I will see that these are identical. So to calculate the standard deviation of original data, I can directly calculate the standard deviation of the coded data. Now, how that translates into a formula. So if I look at the formula of the standard deviation, it is under root sigma x square over n minus x bar whole square, where for x bar, I can recall that x bar would be sigma x upon n. So I can rewrite the formula of standard deviation as under root sigma x square over n minus sigma x over n whole square. Now, since we have just concluded that if I have a constant shift to every value of data, the standard deviation will remain same. So if I have a coded data where I have sigma x minus a whole square and I have sigma x minus a, if I do sigma x minus a whole square over n, comparing it with this part of the formula, and sigma x minus a over n whole square, comparing it with this part of the formula, so that means this will give me the standard deviation of x minus a. And that must be equal to the original standard deviation of x. So original standard deviation of x can be directly calculated by using data in this particular coded form. Likewise, if I have standard deviation formula for frequency table, which is sigma fx square over sigma f minus x bar square being square root. So if I have a coded data, I can directly calculate the standard deviation of x minus a. Not to forget that x bar is equal to sigma f x over sigma f. So if I replace it with the coded data in place of x square, I'm going to get x minus a whole square. So it will become sigma f x minus a whole square over sigma f. And in place of x bar square, I'm going to get sigma f into x minus a over sigma f whole square. This will get me the standard deviation of x minus a, which should match the standard deviation of original x. So I can use this formula for raw data and use this formula for the frequency table to directly calculate the standard deviation. These formulas are going to be given to you, and from here you can directly deduce these formulas for standard deviation. What you have to keep in mind that a constant shift to every value of data would cause that constant shift to the mean value, but the standard deviation would remain unaffected. So if I have a coded data, I can directly find out the mean of that coded data, and then I can add or subtract a constant to get the original mean. Also, I can calculate the standard deviation of the coded data, which would be equal to the standard deviation of the original data. Let's see how that is being asked in a question. I have a set of data where I have sigma x minus 10 equals 15 and sigma x minus 10 whole square equals 200 for the set of data, which is 5 in number. I have to calculate the mean and standard deviation of the original data. So I will write down the formula. Sigma x minus a over n plus a would be the mean, which is going to be 15 upon 5, and then I will just add a constant which is subtracted from every data, that is 10, and I will get myself the mean value. That's coming out to be 13 in this case. And to calculate standard deviation, I can directly use the coded data, which is sigma x minus a whole square over n. In this case, that's going to be 200 over 5 minus sigma x minus a over n whole square, which in this case is going to be directly 15 upon 5 whole square, and hence I will be able to get myself the standard deviation. Let's have a look at another example. I have sigma x minus a as minus 78.5 and sigma x minus a whole square as 2325, and I know that the mean of these values is 9.75. We have to find the constant a. So recalling the formula for mean, x bar is sigma x minus a over n plus a. I know the mean, I know sigma x minus a, I know n. I can rearrange this equation to get myself a. And then after I have gotten the value of a, then I can calculate the standard deviation as sigma x minus a whole square over n minus sigma x minus a over n whole square. So once I do that, I will be able to get myself the standard deviation. Let's have a look at one of the past paper questions where it says that sigma x minus 110 is minus 47.2 and sigma x minus 110 whole square equals 5460. We have to calculate the mean and standard deviation of their speeds. So applying the formula for the mean, sigma x minus a over n plus a, x bar is going to be minus 47.2 over 30 plus the constant, that's 110 in this case, and I will get myself the mean value. Similarly, applying the formula for standard deviation, sigma x minus a whole square over n plus sigma x minus a over n whole square. So that's going to be 5460 over 30 plus negative 47.2 over 30 whole square, and I'll get the standard deviation. So guys, I hope this video helped you towards identifying how to use coded data to get yourself the mean and standard deviation. If it did help, a like and a subscribe would be really appreciated.